Last time in class, we discussed simplifying radicals. Today, we're going to go over radical operations. The first one we'll talk about is multiplying radicals. When you multiply radicals, you can either put them together or separate them. Just like on our notes here, it says the square root of a times the square root of b equals the square root of a times b. So let's go through a couple of examples so you'll be able to see the difference. So if you look at example 1, the square root of 3 times the square root of 15. Neither one of them are perfect squares. So I would multiply them together and you get the square root of 45. You can simplify using the ladder that we discussed, and I'll just show you the ladder. And we get 9, 3. So it's 3 times 3 times 5, and we have our 2 for 1 split. So the answer is 3 radical 5. Or maybe you saw that 45 is really the square root of 9 times the square root of 5, because 9 is a perfect square. So you got 9 radical 5. If you look at our next example, though, there's numbers in front of the radical. And numbers like to stay together, and radicals like to stay together. So you would multiply 15 times 1/3, and you would get 5. Then you would multiply 7 times 14, and you get 98. The 5 stays out there. You must simplify 98. 98 is not a perfect square, but I know it's 49 times 2. And we know that the square root of 49 is 7. So you would write it as 5 times 7 radical 2. Or your final answer would be written as 35 radical 2. Okay, I want you to go ahead and we'll do the first practice problem together. So our first practice is the square root of 3 times the square root of 50. I say to myself, well, neither one are perfect squares. So I'm going to go ahead and multiply them together, and I get the square root of 150. If I say 150, oh, do I know anything that's a perfect square? I do, right? It would be 6 times 25, and we know that 25 is a perfect square, so the answer would be 5 radical 6. So you go ahead and do C, B, and D. Go ahead and hit pause for now, and when you're done, come back and check your answers. Now, you may have simplified your radicals in a couple different ways, but the answer you should have gotten for B would have been 2 radical 21, C 120, and D comes out to be 16 radical 6. So if you need to go back there and review those again, you can. The next part of our notes is going to be on dividing radicals and what do we need to do when we divide radicals. So it kind of works the same way. When you divide with radicals, you use the quotient property. Basically, should you put them under one radical or should you separate them and put them under 2? Okay? Something to keep in mind, and we'll address this more next class, though. You may never, ever, ever have a radical in the denominator. So let's look at our first example. The square root, and it's 7 divided by 16. So if you know your perfect squares, number 1, you're going to say you can't simplify 7 and 16. The answer is no. So I say, can you simplify? No. Then separate. And this is what I mean by separate. Make them 2 different radicals. Because you know 16 is perfect, so the answer to this would just be the square root of 7 divided by 4. And you're done. Now, if you look at our next example, they're already separated, but I notice that I could simplify. So if I make it 1 radical, I have 12 divided by 2, and we all know that that's 6. So the answer is the square root of 6, and you cannot simplify 6 any longer. When you divide or multiply, when you get your final answer, you must make sure that it is in simplest form. Okay, so let's do the first practice together. Actually, we're going to do E together, and then I'm going to let you guys practice the rest, and we'll put the answers up. So let's look at E. OE. 48 and 81. Well, it doesn't divide evenly. So, and I notice that 81 is a perfect square. So I am going to separate. Oh, good, I'm halfway done because I know the square root of 81 is 9. And then I have to simplify the square root of 48. I know my multiplication facts. I know 48 is 16 times 3. If you need to make the latter to prime factor it, you can. So I could write this as the square root of 16 and the square root of 3. We all know the square root of 16 is 4, and radical 3 is already in its simplest form, divided by 9. Okay, so now you take a minute and go ahead and work on the other problems, and then come back to check your answers. Okay, so go ahead and check your answers for all of the problems. If you look at number 3, it's a great problem because the square root of 9 is 3 and the square root of 121 is 11. D and F are more of the types of problems that you guys will see in your assessments. So you have to keep numbers together. So and that's why I put the line there. 4 divided by 8 is 1/2. And then I put them together because 15 divided by 3 is 5, and then I'm finished. And F is kind of clever too because you should be able to see I can simplify that and then just multiply it by 7. Go ahead and move to the next thing that we'll do, and this is adding and subtracting radicals. Okay, what's really important here, you must have like radicands as in combining like terms. Just if I had a problem that said 3x plus 4x, you would tell me that the answer is 7x. But if I had another problem that was 3x squared plus 4x, you would tell me that's already in simplest form. I've already combined all the like terms. So if I look here, the first thing that you have to look for is the radicand. Oh good, they're the same. And you just add or subtract the numbers in front. So we would say, oh, what's 2 plus 4? And we would get 6 radical 5. That's our final answer. But of course in the next problem, the square root of 18 minus the square root of 2, the radicands are different. But you cannot just say, oh, it's in simplest form. What you need to do is simplify 18. So when you simplify 18, it comes out to be 3 radical 2 minus the square root of 2. Then you would combine your like terms, and then the answer comes out to be 2 radical 2. All right, let's look at practice A. Oh, great. The radicands are the same, radical 3 and radical 3. So 8 minus 1 is 7. So our final answer is 7 radical 3. What I would like you to do is the rest of the problems there, D, B, E, and F. And look at D. Right away you can see the radicands aren't the same, but you need to simplify 128 and 32. So go ahead and do that now, and then check your answers when you're done. Now come back and look at your answers. If you noticed in D, I simplified everything, and then I circled 8 minus 3 plus 4. Since the radicands were all the same, all you do is add the coefficients in front. On example B, I have 32 again. 32 simplifies to 4 radical 2 plus 2 radical 2 gives me 6 radical 2's. And then E is interesting because you distribute, right? You guys all know how to distribute. But on this one, we're just distributing radicals. So radical 3 times radical 12 is 36. Radical 3 times radical 3 is radical 9, which you know is 3. So then I use order of operations, and I should have come up with, that should be negative 12. And then on C, you look and you're like, the radicands aren't the same, I have to simplify it. It comes out to 21 radical 5 plus 4 radical 5. So if you needed to go and practice simplifying, now go ahead and do that, but here's your final answers that you need. Next, you'll get some practice problems and then homework tonight.